Hello, we are Project 2 for 023 Chemotherapy Port App. My name is Lillian Wu. I'm a biomedical engineer and the team lead.
Hi, my name is Catherine Kalma, and I'm a biomedical engineer and procurement lead on this team.
Hi, I'm Michael, and I'm an electrical and computer engineer, and I am the hardware lead.
Hi, I'm Adrian Corey. I'm an electrical and computer engineer, and I am the front-end lead on this project.
Hello, I'm Oliver Sostrom. I'm an electrical and computer engineer, and I'm the back-end lead on this project.
Cancer patients receiving chemotherapy are at high medical risk, especially when they're receiving these chemotherapy treatments at home, away from the hospital. A recent medical survey found that from all cancer patients' visits to the emergency department, almost over half of them were potentially preventable. Our solution, as CytoCheck, which is what our smartphone app is called, is aimed at minimizing cancer therapy-related medical emergencies. Our key components are that we are an Android-based smartphone application. We have wireless biometric recording, symptom monitoring, threshold breach detection of these symptoms, and direct provider-patient communication. How we approached this problem was by talking to our sponsor's medical consult team, as well as speaking to other healthcare workers in the field, and conducting literature research in PubMed. From there, we were able to create a list of medical needs that we needed to address within our product. Those medical needs, we were able to directly create functional requirements, and from there create system requirements to verify and base our system's design off of. Here's a chart flowing our medical and user needs to functional requirements. Some notable ones are row 2, where we have to ensure the security of private health information of our patients. We do this by enforcing standards such as IEC 62304 and FDA 524. We also use HTTPS encryption and token-based authentication. Another notable one is monitoring for symptoms of cardiac arrest, bradycardia, and tachycardia. We address this by using a heart rate biosensor.
Pictured here is our system block diagram. We can see that there are 3 subsystems: the external sensors, the front-end mobile application, as well as the back-end. The external sensors are composed of third-party biometric devices that will transmit data via AMP+ and BLE. The application contains 2 graphic user interfaces, which are one for the patient and one for the provider. The backend contains Amazon Web Service hosting and the database. This subsystem deals with server requests and responses. From our functional requirements, we developed 25 system requirements in 5 categories, which are performance, software development, user interface, design features, and instrumentation. Some key requirements include 1.1 and 1.2 to verify software response times to ensure user experience is smooth and as efficient as possible. We also have verifications 5.2a and 5.2b for data safety to ensure no data drops between the biosensors and the database. For each requirement, we established a verification method, which is shown in the second column. T stands for test, A for analysis, D for demonstrate, or I for inspect. We also identified associated subsystems as well as limits or references for each test in the third and fourth column.
So first we're going to go into a patient GUI and their account creation. So first we can click the Don't Have an Account button and go to the sign up screen where patients and providers can enter in fields for a new account. Then they can use that information to log into their account, where here we simulate a patient account where they have a link and view new providers button at the top, which can associate them with the new provider. We've got graph displays, we've got pain, fatigue, and nausea sliders, where patients can input a scale on how they're feeling at that current moment. And then we've got additional survey and sensor buttons at the bottom. So next we're going to go into a provider account. So this has been pre-created, and we can go ahead and see that they have a referral code, a list of patients, and also a list of notifications and any requests from their patients. On the patient view, we can see contact information, thresholds, where you can enter a lower bound and an upper bound. That is a safe range. And then we can also see any additional patient data and graphs.
So in the homepage, we can connect to biosensors. And if your both biosensors are on, we could actually choose one BLE and one AMP+ minimum to connect to. Then we're brought to our data readout page, where this data gets stored in our database, and then we could go back to the homepage, click on display graphs, and have 3 views: daily, weekly, and monthly.
Our system uses JWT verification in conjunction with HTTPS to meet data safety standards. We'll be using curl to demonstrate the necessity of JWTs as well as the use of HTTPS. Curl simulates the exact same request that our application is sending, so the behavior of these curl requests matches what happens with our actual application. Here, I demonstrated how JWTs are generated. Basically, when a login request is sent, the server returns a JWT. This is a unique identifier that is used to give certain permissions to specific user accounts. These allow us to control what accounts have access to what commands, so a third party can't spoof our request to gain access to patient confidential information. You can see here, I demonstrate a curl request that does not have a JWT. We receive an authentication error from the server, meaning no confidential information is released. Then, when I send a curl request with a JWT, you can see the query is successfully authenticated and fulfilled by the server. You can also see in both of these examples, the URL endpoint I'm hitting has an S at the end of the HTTP, meaning all traffic over the internet is encrypted. This combination of both of these methods fulfills our data security needs.
So a patient can take the referral code from the provider's GUI and enter it in on the link and view provider screen, and they can request that an association will be made with their provider. The provider can then refresh their page and see the inbox notification and go ahead and approve or deny that patient. And then once they do that, the patient can see that they are connected with their provider. So the patient has this emergency alert button, which they can press, and a notification will pop up at the bottom saying an emergency has been sent, and the provider will get a push notification to their phone and also a message in their inbox saying an emergency from a patient has been detected.
Innovation does not happen without challenges. Some challenges that we as a team had to overcome include planning, organization, and hardware compatibility. Planning and organization challenges include factors such as scope creep and long lead times. We learned that we need to be definitive with our change deadlines and communicate within our team and to our sponsors on a regular basis. As for wireless communication, the selected temperature sensor did not have ANT+ compatibility, which required us to develop 2 separate pathways and develop BLE connectivity options. I would like to give a special thank you to our sponsors over at Becton Dickinson, Megan, Sangeeta, Mick, and Elaine, as well as our class mentor, Sardar. Thank you.